Welcome to another unit of the ISM exercise set Business Mathematics. This time with a unit on matrices. Let's have a look at the exercise. Here we have given two matrices, large A and large B. And our task is for which value small a and small b are the two matrices A and B invertible. In part 2, calculate the following matrix, the transpose of the inverse of A times the inverse of B. So let's work our way through this step by step, in particular as we need the answer of A to actually be able to do B, because we need to exclude the values for A and B for which the matrices are not invertible. So if we start with A, we have these two matrices, and to determine whether they are invertible or not, we can calculate the determinants. Determinants here, that's the element on the upper left times the element on the lower right minus the element on the upper right times the element on the lower left. So for A, it's 2 times A minus 5, giving us here 2A minus 10. And this expression is 0 when A is 5. So meaning, as we know, a matrix is invertible exactly then when the determinant is different from 0. We can say matrix A is invertible for all real numbers except for 5. So this is the first part. If we do the same thing for B, our inverse here is 1 times 1 minus B times 0. So the determinant is always 1, meaning in this case my matrix is always invertible. So here I only have to exclude the value small a being equal to 5. Then I can turn to step 2, to B. Here, first off, I need to calculate the inverse of A and B. So let's start with A. So we take the matrix A, make a vertical line, and put the unit matrix to the right of this. And then we apply the Gauss algorithm so long that on the left we have the unit matrix and on the right whatever will be there will be our inverse. So to get this, we start by dividing the first row by 2 and the second row by A minus 5. We are allowed to divide this by A minus 5 because we said the matrix is invertible for any value A unequal to 5, so we excluded 5. This then will look like this. So we see we achieved our goal. The left side matrix is the unit matrix. So this means the matrix on the right is the one we wanted. That's the inverse of A. So here we can say that's our inverse of A. So we done the first step. The second step, we have to do the same thing for B. So here we want B, or the inverse of B. So we copy B, or vertical line, unit matrix. Then the only thing we need to get rid of is the B in the upper right. So what we're going to do here, we're subtracting from the first row B times the second row. That's allowed due to the Gauss algorithm. So if we're doing this, results in the following step. Here we see as well, on the left side, we already have the unit matrix. So what we have on the right side must be our inverse of B. So our inverse matrix of B is 1 minus B, 0, 1. Meaning we have matrix, or the inverse of matrix A, the inverse of matrix B, so we can multiply both of them. That's what we are going to do here. Given the two matrices, we can multiply them and then transpose the result. If we multiply them, we use the so-called Falk scheme, meaning we put them here in the 4-quadrant part. We put the left-sided matrix, so A, the inverse of A, in the lower left, and the right-sided matrix in the upper right. And then we, for the multiplication, consider the corresponding column and the corresponding row. We multiply all the elements and add up the results. So for the first entry, we have 0.5 times 1 plus 0 times 0, having 0.5. Then for the next element, we have 0.5 times minus b plus 0 times 1, giving us here minus 0.5b. The lower left, we have 0 times 1 plus 1 divided by a minus 5 times 0. So 0 plus 0, giving us here 0. And then in the final entry, we have 0 times minus b and 1 times 1 divided by a minus 5, giving us here 1 divided by a minus 5. So the matrix in the lower right, that's inverse of A times inverse of B. So the only thing we need to do is transpose this matrix. Transposing here means columns and rows switch places. So whatever was written in the first column now is part of the first row and vice versa. Meaning, we take the matrix we just calculated, transpose this, so the 0 and a minus 1/2 b switch places, giving us our final result, our matrix 0.50 minus 0.5b, 1 divided by a minus 5. This then concludes this exercise, and I hope you enjoyed listening to it. And if you want to see more of these types of exercises, feel free to visit the rest of this exercise set or the corresponding playlist. I say goodbye and see you next time.